This lecture is about simple machines. So simple machines do not change the amount of work done. The amount of work done will always be the same. What a simple machine will do is make work easier. The way that you can make your work easier is by lowering the magnitude of the force applied by increasing the distance the force needs to be applied over. So what that means is, if I am applying a force, my force is going to go down, but my distance is going to go up. And that's how a simple machine will work. It brings your force down by increasing your distance so that you use less force to do the same amount of work. Simple machines can also change direction. So the work done is always the same. The simple machine just makes it so you can lower your force. Okay, so when we talk about work, we know work is force times distance. So when I add in a simple machine, your work that you need to do doesn't change. That number will remain the same. What will happen is your force is going to lower and your distance is going to increase. So let's look at an example here. Let's say you're doing something and you are doing 10 joules of work, and the way you're doing this is you're applying 2 newtons of force over 5 meters. Now notice, the distance formula is the distance the force is applied over, not the displacement of the object. So that means it's the distance the force is applied over. So let's continue. Now let's say I added a simple machine into this issue here. If I had a simple machine, notice my work is still the same. It's 10 joules. But my force has decreased. I've gone from 2 newtons to 1 newton. My distance has increased. I've gone from 5 meters to 10 meters. So I decreased my force and I increased my distance, and I have the same amount of work done with a simple machine. Let's see if I get even smaller. So let's say I use a simple machine, and now I only need to apply 0.5 newtons of force over 20 meters. This still gives me the same amount of work, but I'm using much less force to get the same amount of work done. So when we talk about simple machines, there are 6 types: the pulley, the inclined plane, the lever, screw, wedge, and wheel and axle. I'm going to be talking about the pulley and the wheel and axle today. So when I talk about a pulley is basically a wheel with grooves in it, and then there's either a cord or a rope that kind of goes into that wheel. So pulleys can either change the direction of the force or reduce the amount of force needed to do work by increasing the distance. So a pulley, basically you usually see this, it's attached to something and it'll help raise it up. When you pull on the string, you raise something up. So think of like a sail on a sailboat. You usually pull a pulley and that raises the sail, or a flag on a flagpole. That's usually a pulley that you raise the flag with. So one thing a pulley can do is it can change the direction of a force. So when it's changing the direction of the force, what that means is your magnitude and distance of the force remain the same. So in this example here, my magnitude of the force is 5 newtons on both sides, right? I'm pulling the pulley with 5 newtons of force, but I'm also lifting 5 newtons. So they're equal, my magnitude of the force. My distance the force is applied is 1 meter and 1 meter. So if you think about it, the magnitude and distance of the applied force is exactly the same. What's happening here is the direction is different. So even though I'm pulling from this way, the force is actually this way because the pulley mechanism. Let me show you another example of this. So with this pulley here, this one looks a little more like a common pulley you would see. When you are standing at the bottom of the pulley, you are going to pull down on the pulley, right? So you're pulling down on the pulley, but in reality, your force is actually pulling up. So even though you're pulling down, the direction of your force is changed. The direction is now changed to up. And that's why you can lift this object into the air even though you pulled down, you're still lifting it with an upward force. So the pulley is changing the direction of the force. So another thing that a pulley can do is, if you want to use less force but still complete the same amount of work, a lower force must be applied over a greater distance. So let's look. In this pulley system here, I have 2 pulleys. And notice on this side of the pulley system, I've got a 5 Newton briefcase over 1 meter of string, right? So I know from my work equation, work equals my force times my distance. So the amount of work being done is 5 joules, right? 5 times 1 is 5. On the other side of the pulley, look what's happening here. I have 2 meters of rope and I have 2.5 newtons of force being used. So let's do the work equation again. Work equals my force, which is 2.5, times my distance, which is 2. I still have 5 joules of work happening. So how do I have the same amount of work happening, but I'm applying less force? What happened here is basically this force can be less because I'm applying it over a larger distance. So because I use 2 meters of rope on this side, I only have to apply 2.5 newtons of force to lift a 5 Newton object. Normally, if you tried to lift this, you would need to apply 5 newtons of force to lift a 5 Newton object. But in this case, because I'm extending the distance, I can use less force to lift the object, which means the simple machine would make it easier to lift up this briefcase. So when we talk about these pulleys, they have an ideal mechanical advantage, or IMA, and this refers to how much a force can be amplified by a simple machine. So what that means is, in the last example, I had a force here and it was 2.5 newtons. So I'm using a 2.5 Newton force to lift a 5 Newton object. I only have to use 1/2 of the force normally needed to lift the object, right? Because it's a 5 Newton object I'm lifting, but I'm only using 2.5 newtons of force. So that means my IMA is going to be 2. This thing gives me a 2 times advantage. Every time I use a force, I'm multiplying it by 2. So let's look at some problems here. So the way we solve this is we do the length of the string pulled divided by the height of the object lifted. So a person using a pulley system pulls 30 meters of rope to lift a box 10 meters high. What is the IMA of the pulley system? So let's draw a picture really quick. I have my pulley here. At the bottom of it, I've got a person pulling, and at the top, I have a box. So I know that I use 30 meters of rope. I also know that the box is 10 meters high. So right away, I know I can solve for my IMA. It's the length of the string pulled, which we see is 30 meters of rope, divided by the height of the object lifted. So the height is 10 meters. So in this case, my IMA is 3. What that basically means is any force I apply over here, any force I pull with, is going to be multiplied by 3 on the other side. So I can lift 3 times my strength with this pulley, because any force I apply, if I apply my maximum force here, 3 times that force will be applied on the other side. Okay, let's try another practice example.